Assalamualaikum and good day to all. My name is Muhammad Laduni bin Aslan. Today, I would like to present my final year project entitled Design of Combined ANFIS-FFNN tool for locating precise fault point with GPS coordinates in a test distribution system. Distribution systems are continually exposed to fault occurrence due to various reasons, such as lightning strike, failure of power system components due to aging of equipment, and also human errors. These phenomena affect the system's reliability and result in expensive repairs, loss of productivity, and power loss to customers. When a fault occurs on a distribution line, in order to improve service efficiency, the utility needs to locate the fault location as quickly as possible. In this study, a method of combined ANFIS-FFNN is used to identify precise fault location. To continually supply electrical power, the fault must remove, and restoration can be done safely. A precise identification of a fault point is required to enhance the reliability of the distribution system. Problems of aging equipment, severe weather, and many others that occur in the distribution system are inevitable. Fast and accurate fault location plays an important role in increasing the system restoration, reducing outage time, and great financial losses, and lastly, improving the reliability of the system. Various automated fault location methods have been proposed, but all of them involve very complex algorithm, very complex calculation. Some of the methods request high cost installation. My objective is to design a fault location system of GUI base that can determine and locate a precise fault point with longitude and latitude using combined ANFIS and FFFN approach. To achieve the objective, the scope of this project includes the selecting of the test feeder in which IEEE34 node test feeder acts as a test system network. The scope also includes the training of ANFIS-FFNN block using the inputs and output data, creating of ANFIS-FFNN block for latitude and longitude, and lastly designing of GUI and programming the code for GUI functioning. Methodology. The procedure involved in the project is select test distribution network. Second is data collection. Then train and test data for identifying latitude and longitude point. And finally, design GUI and programming the code for GUI functioning. IEEE34 node test feeder, which is used as a test distribution network, and it can be known as a dummy network for identifying the geographic coordinate system for each node for the network. The test distribution network is matched with the location of Selangor land. Each node represents different location of latitude and longitude coordinates. The table shows the distance between each node or location whereby every node has respective latitude and longitude. The actual location has been assumed for this configuration in which the distance between each node have been matched with the actual map with the same distance. Table 2 shows the longitude and latitude of each node that was identified. Each node represents different location of the possible location that fault could be happen. The proposed fault location method that will be used in this project is combined of ANFIS-FFNN concept, which could predict the fault point with precisely in terms of longitude and latitude. First, we need to train the data by using ANFIS approach. There are several steps involved in ANFIS training procedure. Step 1. Create system using MATLAB code by considering 3 inputs and 1 output. Then, repeat step 1, but this time, the output will be the longitude. ANFIS approach concept as a simple data learning technique because it uses a fuzzy inference system model to change the given input into a target output. ANFIS is a combination of fuzzy inference system and ANNN. It is a multi-layer feed-forward network which uses neural network learning algorithm and fuzzy reasoning to map an input space to an output space. Then, for FFFN training, we will use output of ANFIS training data as input for FFFN training. We will create 2 blocks of FFFN block same as ANFIS training. The first block for latitude, the second for longitude. The application of GUI is a human-computer interface that will help humans to have interaction with computers. It is also known as the pictorial interface that can interface to a certain program. It uses the windows that have icon menu to control with just a click on the mouse. The components of GUI that are being used in the system are push buttons, edit box, and static text. Three-phase fault current as an input where it should be inserted in an edit box under IA, IB, and IC, and then click on push button to see the result as an output in form of latitude and longitude. The output will be displayed in the edit box under latitude and longitude block. Figure 2 shows that the design of GUI using an application in MATLAB that is designed with the outputs. Result and discussion. From the result of the ANFIS train data, it shows the train and the expected data have similar value with a small error. This train data will be used as input for FFNN training. Figure 3 and Figure 4 shows the ANFIS prediction errors and RMSE curve for the latitude respectively. RMSE curve is used to measure the difference between the expected output and the output that have been trained in ANFIS. It still has the error, but there are some ways that are used to reduce the error. The type that is chosen for the implementation is Sugano type. It is chosen because of the good and the accurate prediction that the other type of ANFIS training. Each of the ANFIS block has 3 phase current as the inputs. This training session also applied for the data of the latitude and longitude. This is the block combination of ANFIS-FFNN training created using MATLAB Simulink. Output from ANFIS training will be using as input for FFN training. Thus, in Figure 5, you can see after the input went through the fuzzy logic control, it became an output, and the output is used for FFN training as input. From the result of FFNN train data, it shows the train and the expected data have similar value with some more error. Lastly, a GUI block able to display the output of the system as shown in Figure 6. When the input 3-phase current and voltage are inserted in the push button is pressed, the output of the fault location will be appear in the form of latitude and longitude. The system can show and display the train data using combined ANFIS-FFNN approach. This system can be functioned when the user insert the value of the IA, IB, and IC. Then, the user press the push button and the result of the train data and ANFIS-FFNN will be displayed. In conclusion, power restoration can be done in a short time when the faults in the power distribution system are accurate and precisely located. For that to happen, a graphical user interface GUI is designed. IEEE34 node test header is selected as the network or dummy network for locating the fault point in the power distribution system. The network is constructed in Simulink MATLAB to get the data of the input and output for the system. An application of fault location method for locating fault in a test distribution network has developed by approaching the ANFIS-FFNN method. This method uses 3-phase current as the input and the output where the latitude and the longitude. From this method, maximum error ANFIS is below 5%, so the system can be an effective design in determining the fault point in the test distribution system. That's all from me. Thank you.